Hello geometry students, and welcome back to a brand new video lesson as we get into the second part of chapter 8 and we look at perimeter of polygons and understanding how to calculate the perimeter so that we can apply it to real situations. So the definition of a perimeter is the sum of the lengths of the sides, like the outside of a particular shape. And the more we understand about how to come up with perimeter, the easier it becomes to apply it to real life situations. So for example, letter A, write a formula for the perimeter P of each of the following. A square that has a side length of m. So if I've got this square over here, where each side length is m, so m and an m and an m and an m, we would add them all up. M plus m plus m plus m, or the perimeter equals 4m's, 4 times m. Well, what about a rectangle that has side lengths of r and q, right? R and q. Well, the perimeter here would be 2r's plus 2q's. Okay, 2 of the r lengths and 2 of the q's. What about a regular octagon that has a side length of r plus 1? Right, so if I have this octagon, 1, 2, 3, 4, 5, 6, 7, and 8, it's a regular octagon, meaning all 8 sides are that r plus 1. We would have a perimeter that equals 8 times r plus 1, whatever the r value is. And so you can see how these different types of formulas will help us. Okay, now how do we apply that and what do we actually do? Well, here's an example of applying it to finding the lengths of a kite. Okay, a kite, the ratio of those lengths of those two sides is 3 to 5. If a perimeter of the kite is 48, what are the lengths of the sides? So remember, we discussed that a kite, when we talked about kites earlier, definition of a kite meant these two sides had to be the same and these two sides had to be the same. If the ratio is 3 to 5, we could pretend or imagine, well, what if these were 3 and 5, right? 3 to 5. The perimeter of that would be 6 plus 10, or 16. But notice they're telling us that the perimeter of the entire kite is 48. 48. So what we can do is take that total 48 and divide it by 16 to figure out a factor that we are off by. So we're off by 3, a factor of 3, meaning I could multiply everything by 3 in that kite. So that if I had this kite as a 9, 9, 15, and 15, the perimeter would be 18 for the 2 9s and 30 for the 2 15s, or 48. So you can see how knowing what the perimeter and definition of a kite are helped us to figure out a 3 by 5 ratio for those lengths. Now, a little bit of what you worked on yesterday was problems that look similar to this, all right? Finding the perimeter. Now, if we look at this first shape over here, I'm going to outline in red what the perimeter actually is, right? There's the whole perimeter, okay? Meaning I don't need all of the information. I need this side. Well, if that top part of the rectangle is 8, I know that is 8. I also need this side down here. For this length, we've got to relate to this half circle. If I know that the radius of this half circle is 6 because they labeled it, what does that tell me about this diameter right there? That diameter. Radius is 6. The diameter is 12, meaning this side is also 12. So now I know the three sides of this rectangle are 8, 12, and 18. What I don't know is this arc, or this half circle. Remember, perimeter is like circumference for a circle. So circumference is normally equal to 2 times pi times my radius, or in this case, 2 times 6 times pi, or 12 pi, but we only have half a circle. So I'm going to divide it by 2 to show that it would be 6 pi. So this entire arc out here will be 6 pi. So the perimeter of this non-regular polygon is going to be the arc, which is 6 pi, plus the 8 from the bottom rectangle part, plus 12 from the other side, plus 8 more from the the top side. Right? 1, 2, 3, 4 pieces. 8 and 12 is 20. 20 and 8 is 28, or we get 6 pi plus 28. If they wanted us to round, they would have given that to us in the directions, and then we would have rounded from there. All right, same concept over here, okay? Same concept. We got to figure out the length of this bottom side, because they don't give it to us, and the length of this short side of that. Well, I know this top part is 15, and I know this part is 7. So if I were to figure out the whole thing, I'm going to add those two together to get 22. And then I know the whole length over here is 12, but this small chunk is 8. That leaves us with 4. And now we can add all of those sides up. 12 and 8 is 20. That makes 35. That makes 57, 64, 68 millimeters by adding all of those sides up. So you do have to find some of the missing information first so that you can go about finding the perimeter. Now, the last one is applying that to a map where, and this is coming from the textbook, which you probably don't have access to, but it's saying that Major Martinez lives in Manhattan, and every morning he goes for a jog. In Manhattan, the streets are 1/20th of a mile apart, and the avenues are 1/5 of a mile apart. He believes he jogs at about a 10-minute per mile pace. One morning, this was his route. So he started here at 8th Avenue, and he ran this way to get to 6th, and then he ran up to 23rd, back across to 2nd Avenue, back up top to 34th, all the way back across to 8th Avenue, and back down to 14th Street. Okay, so he took that path. Well, if he started out at 8th and he ended up turning on 6th Avenue, he went 2 avenues. So I'm going to say 2A right here, 2 avenues. And then from 14th Street, he went to 23rd. 14 to 23rd, that's 9 streets. So he went 2 avenues, and then he went 9 streets. And then he went from 6th Avenue to 2nd Avenue, so 4 more avenues. And then he went from 23rd to 34th, so 11 more streets. And then he went from, 2nd Avenue all the way back to 8th Avenue, so 6 more avenues. And then from 34th back to 14th, which is 10 more streets. So we can use that to figure out that he went a total distance of 12 avenues and a total distance of 30 streets. Okay, and that's information that we need to be able to answer these next questions. Here we go. What kind of shape did his route make? Well, we would call this a non-convex polygon. It is a non-convex polygon. Remember, non-convex means that 2 points connect outside the shape. Right? This point here to that point, they connect outside the shape. How far did he jog? Right? How far did he jog? Well, he did 12 avenues and 30 streets. Each avenue is 1/5 of a mile apart, and each street is 1/20th. So each avenue is 1/5. Each street is 1/20th. So we're going to multiply 12 times 1/5, which is 2 2/5 miles for that part, plus 30 times 1/20th will be 1 1/2. So he ran a total of 3.9 miles. So if we want to figure out if he's running faster than a 10-minute pace, we take the total distance he ran, which was 3.9, and we're going to take the 40 minutes that he ran and divide it by how far we went, 3.9. And that is under a 10-minute pace. I'm not worried so much about the pace as I am about, can you figure out how far he ran for a perimeter of that shape based on the avenues and the streets that he ran. If you have any questions, please make sure that you reach out as you are applying the perimeter to real life situations. Otherwise, until next time, folks, stay safe.